So now let's take all the things we've learned and talk about how we can graph something from the equation without creating an actual table. And that's kind of one of the goals here. The way we do this four-step process here, which actually can be up to 5 steps depending on who you ask and how you do it. First step is to determine whether the graph opens upward or downward. Well, the way we determine that is to look at the B value here. The A value, the number in front of the x squared, and this is positive. Since it's positive, this graph will open upward. So if it opens upward, I'm going to just draw a graph up here, say something like this. Let's say this is the graph. Then if it opens upward, there's an absolute bottom, wherever the vertex is. So we have an absolute minimum. So I'm going to erase that now. Next thing it says is find the axis of symmetry. Well, the axis of symmetry is found by using the equation right down here. So we're going to do the work for B right here. The axis of symmetry is at x equals negative b over 2a. I want to note that for C it says find the vertex, which is just basically finding the next step. So the axis of symmetry is when we need to know our A, B, and C values. We really don't need to know our C, but it's just good practice to actually spell it out each time. So based on the equation, this is what I got for A, B, and C. I plug them in and I get x is equal to negative b, which is negative 4, over 2 times A, which is 2. So I get negative 4 over 4, or x equals negative 1. So the axis of symmetry is at x equals negative 1. It says for C, find the vertex. So the way that we find the vertex is we take the equation, oops, and that's g of x, not an f of x here. G of x is equal to, we've got 2x squared plus 4x minus 2 when x is equal to negative 1. So now we plug in the negative 1. Oops. And when you plug that into the calculator, oh, I'm running out of space there. I get 2 times, and I got negative 1 squared plus 4 times negative 1 minus 2. I hit enter and I get that x is, or that the y value is negative 4. So g of negative 1 is equal to negative 4. So now I have my vertex. The vertex is when x is equal to negative 1 and g is equal to negative 4. Now it's saying find the y-intercept. So I've scrolled over here and I'm going to do part D. Actually, let's see, can we do part D down here? Nope, it'll be better over here. So part D says really to find the y-intercept, this equation has to have, you have to plug x into it and solve for that. So let's see when x is equal to 0. So I plug in 0 and I get g of 0. Oops, I need to tell you that that's what I'm plugging in. G of 0 is equal to 2 times 0 squared plus 4 times 0 minus 2. So g of 0 is equal to negative 2. So the y-intercept is at 0, negative 2. Note that the c value in this case was negative 2, so the y-intercept was negative 2. If the equation is written in standard form, not vertex form, but if it's written in standard form, then the c value is actually the y value of the y-intercept. In other words, it's ax squared plus bx plus c, and c is negative 2. C is the y-coordinate of the y-intercept. So let's go ahead and graph some of this information that we have here. So the first thing I'm going to do is I'm going to change the color here to make it stand out a little bit more, and we'll use red. And we're going to label our graph. Oops, that's just going to be 10 at x, then negative 10 and negative 10 over here. So let's plot the graph here that has an axis of symmetry at negative 1. So I go over to negative 1 and I just draw a line. Oops, you want to ideally have the line actually go straight up this y equals -1, and I'm having trouble, so we'll pause and look at that. Magically we have a vertical line called the axis of symmetry at x equals -1. We also have the vertex at -1, -4. We also have the y-intercept at 0, and we should label that really as -1, -4. And we have the y-intercept at 0, -2. And I don't like the way that -4 is looking there, so I'm going to rewrite that. Okay, so now I have the y-intercept, the vertex, and the axis of symmetry to help me out. I know from the axis of symmetry that the distance that this point is from the axis of symmetry is how far I need to go in the opposite direction to plot another point at the same y value, being -2. So I go 1 unit over to get to the axis of symmetry, so I'm going to go just 1 unit over here. I get the other point here based on the axis of symmetry, and that point really is at -2, -2. I know now that this is a absolute minimum because I just know that was positive. It's going to open upwards, and I have 3 points to graph from. So let's just say I wanted to get another point because I really didn't like the fact that I only have 3 points to use for my graph. Let's say I wanted 5. So let's find out what happens when we plug in 1 for x. And what I'm going to do is I'm going to plug in 1 to the equation, get a number out, and whatever that is, I'm going to have a coordinate, say somewhere up here or up here, somewhere in this general direction. And then I can mirror that point across on the other side. So if I find 1 point, I've got 2. So because I'm running out of room here, I'm going to just make some more room for myself. And I want to plug in for g of x equals 2x squared plus 4x minus 2. Another value when we're saying when x is equal to 1, well, what happens? So then when we get g of 1 is equal to 2 times 1 squared plus 4 times 1 minus 2. And let's use our handy dandy calculator. So let's plug this into the calculator and see what we get. So I've got 2 times 1 close parentheses squared plus 4 times 1 parentheses squared, or closed, not squared, minus 2, and I end up with 4. So now I know that when I plug in 1 at g, I get out a 4. So I got a point at 1, 4. So let's go over the graph and plot 1, 4. So I go over 1 and I go up to 4, and I plot the point 1, 4. Now, like I said, I can mirror this over to the other side. I'm going to have a point somewhere on this horizontal, and it's going to be 1, 2 units from the line of symmetry. So I go over 1, 2. And so now I have another point in here that looks like at -3, 4. So now I have 5 points to draw my parabola from. And parabolas like at this skinny are very difficult to show the curve on. But it's about doing your best. It's not an artistic critique of photographic quality, but you get the idea there of what the graph is going to look like. And what I can do is once I have that graph, I can plug it into the original into the graphing calculator and see if I came close to whatever I needed to have. So let's see, we'll clear this one out, we'll clear all these other ones, and I'm going to plug in, see, 2x squared plus 4x, and it's 4x minus 2. So minus 2. Let's graph and see how that compares to what I have on my paper. Admittedly, the one in the graphing calculator looks 10 times better, but I have it over here and it's looks like it's correct. So let's label the graph. G of x is equal to 2x squared plus 4x minus 2. So now we've taken everything you need to know about the min-max, y-intercept, the vertex, the axis of symmetry, and used that to help us graph.